two signals x of n equal to 1, 2, minus 1 and h of n is equal to x of n cell. The convolution y of n is equal to x of n convolution h of n is. So we have to convolute these two signals. Okay. So x of n convolution h of n, that is our y of n. So for that we will just use the matrix convolution system where we will write x of n over here and h of n over here and then multiply it and write it accordingly. So 1 into 1 it is 1, 1 into 2 it is 2, 1 into minus 1 it is minus 1, again 2 into 1 it is 2 and 2 into 2 it is 4 and it is minus 2 and again minus 1, minus 2 and 1. Okay, and then we'll take it all like this and write the sum of all these. We'll get 1, 2 plus 2, 4 and again minus 1 minus plus 4 minus 1 will give us 2 and again minus 4 and again lastly 1. So this is the answer. Okay, so we'll move on to the next question. Okay, let's do the next question. What is the energy of a signal? Okay, the next question is what is the energy of a signal whose Fourier transform is given below? Okay, so Fourier transform is given here and to find out the energy of a signal, please write it in the formula book. This is the energy of a signal if its Fourier transform is given, that is 1 by 2 pi integral minus infinity to infinity modulus of x of omega square d omega. So this is the formula for finding out the energy of a signal if its Fourier transform is given. Okay, so we'll substitute these in this equation. We'll get 1 by 2 pi integral minus 1 to 0, right? Minus 1 to 0, it is 1. So it will be 1 the whole square d omega plus integral from 0 to 1, it is minus 1 the whole square d omega, right? Which is equal to 1 by 2 pi 1 square into 1 into 0 plus 1 plus again 1 into 1 minus 0. So we'll get 1 by 2 pi into 2, or we'll get 1 by pi, which is equal to 0.3183. Okay, so this is the answer. Now let's do the next question. Okay, let the signal x of t is given by, x of t is given here, let y of t is the even part of x of t, then the energy of a y of t is. So to find out y of t, what is y of t? Y of t is the even part of x of t. So to find out the even part of any signal, the formula is equal to x of t plus x of a minus t divided by 2. Okay, so this is to find out the even part of any signal. So we'll write x of y of t is equal to x of t plus x of a minus t divided by 2. So what is x of t? I'll draw x of t over here. We'll get 2, 3, minus 2 and here it is 2, right? 3, 4 plus x of minus t. X of minus t means its mirror image. We have to take its mirror image. So how will it look like? It will come over here. Okay, so it will look like this: minus 2, minus 3, minus 4. Again this will be 2 and this will be minus 2, and we are going to add these two. Okay, we are going to add these two. We'll get, that is what is going to be done here, and it is going to be divided by 2. The amplitude will be divided by 2. So we'll see how will it look like if it is added together. So amplitude will be divided by 2. It will be 1 this time, and this time this will be minus 1, again minus 3, minus 2, and again at the other side we have this one, right? So here it will be minus 1 as well. This will be plus 1. Okay, so it is 2, 3 and 4, and now we will have to find out the energy of this particular signal. So to find out the energy of the signal, energy is equal to integral minus infinity to infinity x of t the whole square dt. This is a formula for finding out the energy of a signal x of t. Okay, so now it is this particular signal, that is our y of t. So from minus 4 to minus 3 it is 1 dt. From minus 3 to minus 2 it is minus 1 whole square dt, plus integral 2 to 3 it is minus 1 the whole square dt, plus integral 3 to 4 also it is 1 square dt. Okay, which is equal to, and right over here we will get integral minus 4 to minus 3 1 dt, plus again integral minus 3 to minus 2 1 dt, plus 2 to 3 1 dt, plus 3 to 4 again 1 dt. Okay, so solving it we will get 1 plus 1 plus 1 plus 1, so it is 4 joule. So 4 joule is the answer. Okay, now let's do the next question. Okay, given the periodic signal x of t, given the periodic signal x of t is equal to sigma n is equal to minus infinity to infinity u of t minus 3n minus u of t minus 3n minus 1, where n is even, the DC component of the signal is. So this is actually a train. Okay, because it is, as you can see, it is summation. Okay, so first one we can, as you can see, u of t minus 3 and let it be let n be 0. Okay, let n be 0, and it is given that n is always even number. So when n is equal to 0, what will be the equation? It is u of t minus u of t minus 1, right? So at n is equal to 0, it will be like this, u of t minus u of t minus 1. So 0 to 1 it will be like this, and again at n is equal to 2, say n is equal to 2, it will be u of t minus, sorry, n is equal to 1, next one is n is equal to 1, right? So u of t minus 3 minus u of t minus 4, right? Okay, I'm sorry, and it can only be from n is even, right? So I'm sorry, so it is u of t minus 6 minus u of t minus 7, right? So it will look like this, it will be from 6 to 7, and again when n is equal to 4, u of t minus 12 minus u of t minus 30. So it will look like this, 12 to 13, and again in the opposite direction also we will have, when n is equal to minus 2, what will happen? U of t plus 6 minus u of t minus, okay, minus 6 plus 6 plus 5. So it will be like minus 6 to minus 5, sorry, minus 5 to minus 6. So it will look like this. This will be the train, and it goes on and on and on. Okay, so because it is an it is a train. Okay, now we will have to find out what is the DC value. To find out the DC value, the formula is 1 by t, where t is the time period, 0 to t x of t dt. Okay, so this is our x of t, and what is the time period here? It repeats itself after 6 time when t is equal to 6, it repeats itself, and after 6 then also it is repeating. Okay, so minus 6 to 0, again this thing is coming, and after 0 to 6 also this thing is on. That is means the time period is equal to 6. So DC value equal to 1 divided by 6 integral 0 to 1. Okay, 0 to 1, because from 1 to 1 to 6 it is 0, so we don't have to take it. So 0 to 1 it is 1. So 1 dt, which is equal to 1 by 6, the answer will be 0.166. That is the DC value. Okay. Now let's do the next question. What is the period of the signal x of t is equal to sine 2 pi by 5 t and cos 4 pi by 3 t. Okay, so we have to find out the period of this particular signal. So for that we have to change that in some format, that is sine a plus sine a cos b. What is the formula for sine a cos b? Is equal to 1 by 2 sine a minus b plus sine a plus b. So I am going to apply it here. We will get 1 by 2 sine 2 pi by 5 minus 4 pi by 3 t plus sine 2 pi by 5 plus 4 pi by 3 t. Okay, so we'll get 1 by 2 into sine 2 pi minus I will get minus 14 pi t divided by 15, plus here we will get 26 pi divided by 15 t. Okay, so this is x1, this is x2. Now we'll have to find out the period of x1, that is t1 is equal to 2 pi by omega 0. Instead of omega 0 we have 14 pi divided by 15. Okay, so we'll get 15 divided by 7. And again, what is t2? T2 is also 2 pi by omega 0. Here instead of omega 0 we have 26 pi divided by 15. We'll get 15 divided by 13. And now we'll have to find out if this period is the signal is periodic or not. For that we'll divide t1 divided by t2. We'll get 15 divided by 7 divided by 15 divided by 13. We'll get 13 divided by 7, which is rational, so it is periodic. And so to find out the time period t0 is equal to, either it is cross multiply it, we'll cross multiply it 7 t1, or it is 13 t2. Okay, so our t0 is equal to 7 into, instead of t1 we'll write in, so our time period is 15 seconds. Okay, now let's do the next question. Consider a periodic signal x of t is equal to rectangle t minus 1 by 2 with the time period t is equal to 2. Then the power in the first 4 harmonics is. Okay, so I consider a periodic signal. It is given in the question that it's a periodic signal. Okay, so it repeats itself with time period t. So a normal rectangle will look like this. Okay, it will be 1 by 2, it will be minus 1 by 2. Okay, this is a normal rectangular signal with period 1. And now if it is shifted to the right side by 1 by 2, so it will look like this: rectangle t minus 1 by 2, it is shifted to the right side by 1 by 2, so it will look like this, right? So this is our rectangle t minus 1 by 2. And now in the question it is given that it is a periodic signal. Okay, periodic signal, so this will repeat itself after 2. Okay, so 0 to 1, and the next one will be coming at 2 to 3, again 4 to 5 and so on, because it is periodic. Okay, and on the left side it will be okay, minus 2 to minus 1. Okay, so now coming back to the question, we have then the power in the first 4 harmonics is, so we have to find out the power in the first 4 harmonics. Okay, for that we will have to use Fourier coefficients. So to find out Fourier coefficients, we will have to xn equal to 1 divided by t integral 0 to t x of t e raised to minus j n omega 0 t dt, complex Fourier series coefficient. So we will get 1 divided by 2 integral 0 to 1, x of t is 1 over that time period, right? So it is 1 e raised to minus j n omega 0 t dt. Okay, now we will integrate. What we will get? 1 by 2 into integral 0 to 1 e raised to minus j n omega 0 t dt. 1 by 2 into 1 divided by j n omega 0 e raised to minus j n omega 0 t 0 to 1 again equal to so how much it is? Omega 0 is equal to 2 pi by t. So that is equal to 2 pi by t is already given, it is 2. So instead of omega 0 I will write pi. Okay, so that is it, and in e raised to minus j n pi minus 1. Okay, so e raised to minus j n pi is, please keep this in mind, this is equal to minus 1. Okay, minus 1 the whole raised to n. You can expand it and you will get the answer, because e raised to j theta is cos theta plus j sin theta. So for e raised to minus j and pi, it will be alternating between minus 1 and plus 1. Okay, so that is why it is coming here. So we can write, I'll write it over here. We'll get xn equal to minus 1 divided by 2j n pi into minus 1 the whole raised to n minus 1, which is equal to, I will take a minus inside, we will get 1 minus minus 1 the whole raised to n divided by 2 pi j. And now in the question it is asked to find out the power in the first 4 harmonics. Okay, so that will be equal to power. The general formula for power is sigma n is equal to minus infinity to infinity x of n the whole square. So this is Parseval's theorem. So which is equal to, I can write 2 into sigma n is equal to 0 to infinity x of n the whole, so modulus of x of n the whole square also. Okay, so in the first 4 harmonics we will have to see, actually 1, okay, I'm sorry, 1 to infinity. So this will be equal to sigma n is equal to 1 to 4. We have to find out till the 4th harmonic only. So to 1 to 4 x of n whole square, which is equal to x of 0, sorry, x of 1 plus x of 2 plus x of 3 plus x of 4 whole square. Okay, now what is x of 1? X of 1, when it is equal to 1, n is equal to 1, we will get 1 minus of minus 1, that is 1 plus 1 divided by 2 pi j. So that is 2 pi j the whole square plus then x of 2, and it is x of 2, we will get 0, and it is x of 3, that is 1 minus minus 1 only, that is 2 pi j into 3, that is 2 divided by 6 pi j the whole square plus again 0. So what we will get is 2 into 4 divided by 4 pi square j square plus 4 divided by 36 pi square j square. So what is remaining here is, okay, again take 4 outside, I will get 4 and pi square j square outside. J square outside, we will get 1 divided by 4 plus 1 divided by 36. Taking the LCM, we will get okay. One more thing I forgot. We are taking its modulus, right? So j square is equal to minus 1 and its modulus will be equal to 1 only. So no need to take this j square. So what will be remaining is 8 divided by pi square into 9 plus 1 divided by 36. So that is 8 by pi square into 10 by 36. Now we'll see how much it is. Which is equal to 0.225 watt. So this is the answer. Okay, so with that I am going to end this video. In the next video we will be solving some more problems on signals and system. Please do follow my Instagram account as well as where I share study notes, and also in the Telegram group I will be sharing the PDF of this video, as well as some more questions will be solved, and that will be also, those PDFs will also be uploaded in the Telegram group. So thank you for listening. Thank you for